although the statement skeletal muscles produce different forces for different tasks is perhaps not too surprising, but maybe you haven't really stopped to think about how muscles are capable of doing this. So now that we know a little bit about muscle physiology, let's explore how this works. And we'll begin with a concept called the motor unit. So each muscle cell or muscle fiber is served by a single motor neuron from a motor nerve. So where a nerve being a collection of neurons. This motor neuron may branch extensively to make neuromuscular junctions with many skeletal muscle cells. So it isn't uncommon for a single neuron to control hundreds of skeletal muscle fibers or skeletal muscle cells. So the motor unit is defined as a single motor neuron and all of the skeletal muscle fibers that it innervates or controls. So that is, when this one motor neuron is stimulated, it will then stimulate all of the skeletal muscle fibers that it controls, even if it controls a few hundred of them. So in this example diagram on the right, we have two relatively small motor units being served by two different neurons. Motor unit X is the motor neuron and the muscle cells that are colored in red that motor neuron controls. So in this diagram here, there are 5 cells that motor unit X will control. And motor unit Y is the motor neuron and all of the skeletal muscle cells that are colored in tan that it controls. And in this example, in motor unit Y, there are 7 skeletal muscle cells. And notice that each of those motor neurons makes a single neuromuscular junction with the cells that it controls. But notice that motor unit Y has no control over motor unit X's skeletal muscle cells, and vice versa. So, as an example, when motor unit X fires, all 5 of the muscle cells that are controlled by that one motor neuron will be stimulated to contract. The same will happen with motor unit Y. So the more muscle cells that contract during a stimulus, the stronger the force or the stronger the tension the muscle will produce. This will continue up to a point that all of the skeletal muscle cells in the muscle are contracting, at which time the muscle will be producing the maximum amount of force that it is capable of producing. Muscles will produce their maximum amount of force when all of the cells within that muscle are contracting. So in the graph at the bottom of the diagram here, we see muscle tension in grams on the vertical axis, and the stimulus that recruits motor units X, motor units Y, or both motor unit X and Y on the horizontal axis here. So what this graph is showing is that if muscles need to only produce small amounts of force, only a few muscle fibers will be stimulated to contract. So if a task requires only small amounts of force, like picking up a pen to write a note, then only small motor units will be stimulated to contract. So that is, motor units X or Y might be stimulated to contract. And notice that motor unit Y produces slightly more force or more tension than motor unit X because it has 2 more cells associated with it, or 2 more fibers associated with it. So in general, the more fibers that are recruited to contract, the more force or more tension that muscle will produce. So if large amounts of force are required, like when we're picking up a heavy object, then more motor units will be stimulated to produce more tension and more force. So in this example, if both motor units X and motor units Y are stimulated together, and both of those motor units contract, then they will produce more tension than either motor unit X or motor unit Y would produce by themselves.